Okay. Next up, I'm just going to talk a little bit about ionic bonds being soluble and whether ionic bonds are soluble or not, and you should quickly know the answer to this because you already learned about ion dipole attractions. Yes, they are absolutely, they can be soluble. Not all of them are though, okay? So it says here some ionic compounds are soluble, and it also says, but the ion dipole forces between the ions and water must be stronger than the ion-to-ion forces that hold the compound together. Okay, so the ion dipole forces must be stronger than the ion-to-ion forces. And we're going to take a look at what makes them stronger versus weaker on this image at the bottom here. Then I have here, if an ionic compound is insoluble, then the ion dipole forces between the ions and the water are weaker than the ion-to-ion forces. So the full positive and full negative would have a stronger attraction to each other than a polar water and the ion dipole forces. All right, this is one of my favorite pictures. Can't really explain why, just really love it because you can truly see how the water separates the different ions. So this is a salt crystal. We have a crystal lattice here. Now remember, NaCl is ionic. Okay, it's an ionic compound. Now you might be thinking, well, the ion-to-ion forces are always stronger than the ion dipole forces. But take a look a little bit more closely. Look how many water molecules are surrounding this ion. So you see here, or I guess recall that the solvent, which is water, is always present in a greater amount. Okay, even if you put salt on your food, you have much more food and water in that food than the actual little bits of grated salt that you put in there. So what happens is the water molecules, and you'll notice, so because you learned, I don't know what color to use, you learned in the past that the hydrogens become partially positive and then the oxygen becomes partially negative. You see here that the negative chlorine is surrounded by the positive sides, partially positive sides of water. Now what ends up happening is that it eventually separates out that ion from the rest of this crystal lattice. Okay? And then you take a look here, you have the negative sides, the partially negative sides, the negative oxygens of water are surrounding the positive sodium ion here. So what ends up happening is that it blocks it off and it separates it from the rest of the structure. Now the reason that this is a physical process is because if we were to evaporate out these water molecules, okay, they wouldn't be around anymore. If we were to evaporate them out, eventually those salt crystals, the solid, would reform because the ions would be able to feel attraction toward each other again. And that's why if you ever go to the ocean and take a little swim in the water, you end up feeling a little salty after you dry off because the water evaporated out or off of your skin, or it soaked into your skin and it left behind salt crystals. Okay, they reformed.